we are familiar with the two-dimensional planes and shapes. How do we locate a point in a two-dimensional plane? With respect to the distance of the point from the reference axis, that are x and y axis. Now we are extending two-dimensional into three-dimensional. Now, how do we locate a point in a space? Imagine two mutually perpendicular planes and the intersection. Imagine that's a third plane which is mutually perpendicular to both the first and the second plane. Also think about the intersection of the three mutually perpendicular planes. Look at the roof corner. The best example is that we see that the intersection part is the set of three mutually perpendicular lines. Here also the same. Perpendicular planes is a set of three perpendicular lines. These axes are called coordinate axes, x, y and z axis. The point of congruence of the three axes is called origin. Has its own negative and positive side. In the x-axis, OX is the positive side, OX dash is the negative side. Similarly, in y-axis, OY is the positive side and OY dash is the negative side. And in z-axis, OZ is the positive side and so OZ dash is the negative side. Formed by the considering x and y axis together, xy axis, xy plane. Also, yz plane is formed by y and z axis. Now, similarly, zx plane is formed by z and x axis. Planes xy, yz and zx are called coordinate planes in space. We locate a part in space with respect to its distances from the coordinate planes. These coordinate planes are divided into 8 equal parts called octanes. There are second octane, third octane, fourth octane, 5 octane, 6 octane, 7 octane and 8 octanes. Similarly, we have learned it in the earlier classes, x and y axis divided the two-dimensional plane into 4 equal parts called quadrants.